All right, I'm sure you're aware that most of the things that we order from overseas come on massive cargo containing ships. These ships can contain thousands of cargo containers. Many of these cargo containers have cars, refrigerators, any number of things you could possibly imagine. And these things are unbelievably heavy. These ships are heavy. These thousands of cargo containers, they could pile up 12 high. And this massive ship made of steel is able to float on water. Have you ever thought about how that is? I don't float all that great. If you put a whole lot of weight on me, say a refrigerator, I don't think I'll be floating for very long or at all. So it all comes down to density. Density really can be defined as the amount of mass per unit of volume. And that's a kind of a science definition that may not be very satisfying, but it's basically how heavy is something relative to how large it is or how much space it takes up. These large ships are able to float because water is exceptionally heavy. Water is about 8 pounds per gallon. 8 pounds per gallon, that's very, very heavy. And so because of that, these ships are able to displace. As you put the ship in the water level rises. Kind of like when you slide into a bathtub, the water level rises, right? Because you are taking space that the water previously took up. Therefore, the water level rises because it has to fill in around your body. Well, it's the same thing. When we put these massive ships into the water, they displace some amount of water. As long as the weight of the ship is less than the weight of the water it displaces, it will float. It's really that simple. We could continue to make these ships larger. The only problem is that we would have to continue changing the shape of the hull, the bottom of the boat, and ultimately much larger. They're not going to fit through the Suez Canal or the Panama Canal or the other canals that we've cut between continents that allows faster transport. We're already pretty much at capacity as far as size of the ships. Water has a very unique density. You guys need to know this. Water is about, let's put it this way. Density of water is about 1 gram per milliliter. 1 gram per milliliter. So every milliliter of water contains about 1 gram. Again, if you extrapolate that to a gallon, it's about 8 pounds. It's a very, very heavy substance. It's surprisingly heavy. So anything that has a density less than 1 would float in water. So ice is water, but it's in the solid state. Ice, when it freezes, the molecules actually space out to take up more volume. The mass doesn't change, but the volume increases. Because volume's on the denominator, which I'll show you, it actually makes the drop. So ice has a density of about 0.9 grams per milliliter. And for that reason, ice floats. Anything made of ice, now if it's, say, an ice cube in your glass of water or the massive iceberg that took down the Titanic, because density of water is 1 and the density of ice, which I misspelled, lovely, of ice is 0.9, that means 10% always is going to be above the water, 90% is always going to be below. Again, that's true because of math. 90% is the portion that we're not able to see. I always say the tip of the iceberg. Well, guess what? The tip is always 10%. Okay? Same thing in your glass of ice water, 10% above, 90% below. Now, if you add salt or sugar or other stuff or make it into sweet tea or whatever it may be, that does change a little bit through properties we'll talk about much later in the spring semester. But for the most part, density of water is 1. You need to know that. And the density of ice is actually less, which floats. That means that the density of these massive cargo ships must be less than 1. Okay? All right, so density, the equation for density is actually relatively simple. It is, the equation for density is, we just say D for density, is mass divided by volume. Mass divided by volume. That's all it is. That's the formula for density. Some amount of mass per unit volume. Per means divide. So amount of mass over some amount of volume or space will give you density. So you either increase the mass or decrease the volume, and that will increase density. Or you could decrease mass, or in the case of ice, increase volume, and that decreases the density. It's kind of interesting how that works. So in this particular example, it says the density of gold is 19.3 grams per milliliter. What is the volume of 15.5 gram sample? So normally the equation is density equals mass divided by volume, but we're going to have to algebraically rearrange this to solve for volume, because that is our unknown. They give us density and mass as our givens. Our unknown is volume. So if that's the case, what we need to do in order to get V all by itself, I'm going to go ahead and show you guys the algebraic way to do this, and then I'll show you the shortcut, an easy way to remember it, okay? So if density equals mass divided by volume, I'm going to go ahead and write that back up here again. Mass divided by volume. In order to get volume on the left side all by itself, we would need to multiply both sides by volume, because remember, you could do whatever you want in algebra as long as you do it to both sides. What that does is cancels volume over here, so we're left with volume times density equals mass. Everybody see what I did there? I multiplied both sides by volume. Because volume was already on the bottom on the right side, now it's on the bottom and the top. That cancels. So we're left with VD equals mass. If we needed to solve for mass, there we go. We're done. We just multiply volume times density, and we get our mass value. But we need to get volume by itself because that's what the question's asking for. So I'm going to go ahead and divide both sides by density, because if density is up here, I need to cancel it out. So that's going to leave me volume equals mass divided by density. Now, if you notice something, if you compare this and this, do you notice something kind of similar? Do you notice that basically the volume and the density swap places? That's really all that happens. So if you are ever doing an equation like this and you need to solve for the bottom value, in this case volume here, switch it with the density there, and there you go. That's how you do it. So that's just a little shortcut, but basically I did want to show you the algebraic rationale as to how we get this equation here on the bottom. Okay? So if you need me to go over that later, again, just let me know, or your teacher, or whatever it may be. But that's the equation we're going to need for this first question. They already tell us that volume is our unknown. We know that the mass is 15.5 grams. We know the given is that the density is 19.3 grams per milliliter. Again, I'm just following this example right here, this equation. Okay, I'm going to go ahead and get my calculator. Divide 15.5 divided by 19.3 equals, and the answer comes out to be 0.803. Grams cancels with grams. Guess what? You're left with milliliters. There's our final answer. The volume of an object that weighs 15.5 grams and has a density of 19.3 grams per milliliter has a volume of 0.803. So that's a little bit more of an advanced problem. Again, they're not always going to be like that, where you have to algebraically rearrange the problem in order to solve for it, but it's a great way to start because it gets us rearranging equations from the get-go. All right, so a little bit more straightforward examples would be like these two. I'm going to go ahead and do, I'll go ahead and do the top one. It says a piece of metal with a mass of 147 grams is placed in a 50 milliliter graduated cylinder. The water level rises from 20 milliliters to 41 milliliters. So what's the density? So we know that the equation for density is density equals mass divided by volume. We already know that the mass is 147 grams because grams is a unit of mass. But wait a minute, where's the unit for volume? It's typically milliliters. Wow, I see 50 milliliters graduated cylinder, I see 20, and I see 41. What this is talking about is water displacement. Now, at the very beginning of the video, I talked about how when you slide into a bathtub, the water rises a little bit because, again, your body is taking place in some of the water. So the water must account for that and compensate by rising up against gravity. We put a massive boat into the water, the same thing happens, but the oceans are so broad that it's not really going to make any measurable increase in the sea level. So if I could draw you a little picture of what we basically have is a graduated cylinder. Looks like this. Again, you're going to have all the graduations, which are the markings on the side. It's a total of 50 milliliters. They tell us that. It's a 50 milliliter graduated cylinder. And they said that the water level rises from 20, let's just say that's 20, up to 41 milliliters. This is, again, water displacement. This is how you measure the volume of an object that has a very odd shape. If it's a cube, it's really easy to measure volume. If it's a cone, it's a little more mathematically complicated. If it's a cylinder, again, these are ways you can be done using math. But if it's a really oddly shaped object like a rock or something like that that has no straight lines, no hard edges, no smooth surfaces, the best way to do this is with water displacement. So if we have water in there, it was at 20 milliliters to begin with. We dropped it in, bloop, and the water rose up to 41 milliliters. That tells me that the volume of the object is 41 minus 20 milliliters, or 21 milliliters. Sorry, I was getting ahead of myself. 21 milliliters. That if the water rose by that much, that is the volume of the object that we put in to the cylinder. So now I'm going to go ahead and put that into my problem, 21 milliliters. I'm ready to go ahead and calculate. 147 divided by 21 equals a nice round number of 7. Notice the units do not cancel out. We have grams on top, milliliters on bottom. Nothing cancels out, so it's literally gram per milliliter. 7 grams per milliliter. Anytime you see gram per milliliter, gram per liter, that's always going to be a density, mass divided by volume. So that's how to do the second one. We had to find the volume of an irregularly shaped object by using water displacement. However much the water level rose is exactly equal to the volume of the object that was put into the cylinder. Once we found that by subtracting the two values, we put that into the equation in the appropriate place, did the division, and found it to be 7 grams per milliliter. All right. The last one that we have is about a model boat. In this particular case, it says a model boat has a mass of 1,300 grams. What is the volume or minimum volume in cubic centimeters? Cubic centimeters is a volume. Think of a cube. A cube takes up volume. What is the minimum volume in cubic centimeters required in order for the boat to float in water? Again, hint, what is the density of water? I told you at the beginning of the video, the density of water is 1 gram per milliliter, or 1 gram per centimeter cubed. 1 gram per milliliter and 1 gram per centimeter cubed is interchangeable because a milliliter and a centimeter cubed is exactly the same thing. A milliliter is equal to a centimeter cubed. There is no difference mathematically or within volume. So that's another thing you need to know. Centimeter cubed, milliliter, absolutely identical. Okay, so what we have is our original equation, density equals mass divided by volume. That's always your starting point. If we have to rearrange, we can. It's asking for what is the minimum volume. Okay, well, I already showed you at the beginning of the video how to algebraically rearrange to get the V on the opposite side all by itself and the D over by the mass, so we could solve for volume. But if you remember, just as a shortcut, basically these two are going to swap places. So I'm just going to go ahead and do that because, again, that's easy, and I can remember that pretty easily. So really the equation we need to use is volume equals mass divided by density. Okay, that's the exact same thing. We're just solving for a different unit. So what we're going to do is our mass is 1,300 grams, because grams is the unit of mass. Then our, if again our density is going to be 1 gram per centimeter cubed, and again, where do we get that density from? The density of water. Therefore, 1,300 grams divided by 1 gram per centimeter cubed. Grams cancels out. 1,300 divided by 1 is 1,300. Therefore, it would have to be 1,300 centimeters cubed at least in order to float. Okay? Again, that's a density calculation taking a little bit farther to the pre-AP level. Again, the regulars don't quite do it this way. They just solve for density, solve for mass, maybe solve for volume. But again, now we're really applying it into the real world. So again, that is the last of our note packet. So again, as always, thank you guys for watching.